All right, hello and welcome. If you're in grade 9, then you are in for a treat. We're about to dive headfirst into the incredible world of physics. Think of it like this. We're going to learn the official rulebook for the entire universe. It's going to be an awesome ride. So let's kick things off with a little question for you.
Okay, here's a little puzzle. I want you to picture three totally different things. We've got a smartphone, the one you're probably holding or have nearby. Then a huge ancient castle. Think giant stone walls centuries old. And finally, a massive jet airplane soaring through the sky. I mean, on the surface, they couldn't be more different, right? But what if I told you they all share one incredible, fundamental secret?
And the answer? It's actually super simple, but at the same time, it's kind of mind-blowing. Every single one of those things, the tech in your phone, the reason that old castle is still standing, the way that plane can fly, it all works because of one thing: physics. Yep, it's the invisible foundation, the underlying set of rules that makes all of it possible. So what is physics, officially? Well, it's the branch of science that's all about describing the most basic, fundamental aspects of our universe. You can think of it as humanity's grand attempt to understand the how and the why behind absolutely everything, from the tiniest particles you could never see, all the way up to giant galaxies swirling in deep space. And here's a cool little fact. The origin of the word physics gives us a huge clue. It comes from the ancient Greek word physis, and you know what that means? Simply nature. So right from its very core, physics has always been the study of nature. That idea is baked right into its name. But let's be real, nature is huge. I mean, it's everything. So how on earth do scientists even begin to tackle something that big? Well, they do exactly what you or I would do with a giant project. You break it down. You chop it up into smaller, more manageable pieces. And in physics, we call these pieces branches. Think of this as our map to the different lands in the world of physics. First up, you've got mechanics. That's all about motion and forces, why a ball flies the way it does. Then there's acoustics, the sound of sound, from a tiny whisper to a sonic boom. Optics, that's the study of light and how we see. We've got thermodynamics, which deals with heat and energy, the stuff that makes engines run and stars burn. Then there's electromagnetism, a huge one. It's the force behind electricity and magnets, powering our entire modern world. And finally, nuclear physics, where we dive right into the super powerful heart of the atom itself. Each one is a whole fascinating universe to explore. So, with all these different branches, you might think physics just kind of keeps to itself, right? That it stays in its own lane? Oh, not a chance. Not even close. In fact, it's the complete opposite. Physics is the foundation for so many other sciences. Think about it. Chemistry? The rules for how atoms bond are all based on physics. Engineering is basically just physics in action. You absolutely cannot build a stable bridge or smartphone without it. Geology uses physics to understand things like earthquakes, and medical physics gives us amazing tools like X-rays and MRIs. It truly is everywhere. Now, all this knowledge, it didn't just appear out of nowhere. Nope. It was built up slowly, idea by idea, over hundreds and hundreds of years. It's all thanks to these brilliant trailblazers who were brave enough to ask really, really big questions about how the universe works. And here are just a few of those giants we're talking about. We're really standing on their shoulders. It all starts with classical physics, way back in the 17th century. This is where Isaac Newton shows up and lays out the fundamental laws of motion and gravity, the rules for pretty much everything we can see and touch. But then you fast forward to the 20th century and things get wild with the start of modern physics. You have the incredible Marie Curie, whose research into radioactivity unlocked the secret world of the atom's nucleus. They call her the mother of modern nuclear physics for a reason. And then, of course, there's Albert Einstein, who came along and, with his theory of relativity, just completely flipped our understanding of space, time, and the universe on its head. And this is so important to get. These discoveries aren't just dusty old history lessons. They are the very engine that runs our modern world. The electricity powering your screen right now, the medical imaging that saves lives, the rockets that take us to space, you can trace all of it straight back to the breakthroughs these pioneers made. So when you boil it all down, what's the goal here? It's really like two sides of the same coin. On one side, it's about pure understanding, just figuring out the basic rules of the universe, from why things fall to how stars shine. But on the other side, it's all about application. taking that understanding and using it to build incredible technology and open up amazing career opportunities in transportation, medicine, engineering, you name it. Look, people like Newton, Curie, and Einstein changed the world, all because they asked big questions. Your journey into physics is just getting started, and this is your first step. So the question now is, what will you discover?